The most basic idea of thermodynamics that most people have likely heard is the extension of the law of conservation of energy. This is a law which states that energy can neither be created nor destroyed, only transformed. This energy that is mentioned encapsulates all forms of energy of a system which must, by definition of the first law, remain constant. One of the ways in which energy can go in or out of a system is through work. If we consider a closed system in which there is no mass going into or out of this system, we have to realize that there could still be heat and work going into or out of the system. Now in this case, we have something called boundary work, and this is where the boundary in question can move due to expansion or due to compression. For expansion, we can consider the fluid or the system to be doing the work. So we can say that the boundary work is work out. And then for compression, since we will need to use outside or the surrounding environment to accomplish our work, we can say that the boundary work is work in. Visually, we can then define work as a change in volume. And we can also calculate our boundary work using the integral of pressure with respect to the volume from one state to another. Now, we'll take a look at this very simple experiment, which will delve into the first law of thermodynamics, investigating how heat transfer affects gas pressure in a closed system. Here are the materials that we will need: an empty water bottle, a small pot or bowl, a balloon, and a hot water source like a pot or kettle to heat the water. Firstly, we start with the balloon stretched over the opening of an empty water bottle. When hot water from the kettle is poured into the pot containing the bottle, the air particles inside the bottle expand. Here, the heat energy from the hot water is transferred to the air inside the bottle, increasing its internal energy. This increase in internal energy is reflected as an increase in pressure, causing the balloon to inflate. The experiment therefore demonstrates how heat transfer leads to a change in energy within the system, adhering to the principles of the first law of thermodynamics.